Good. I'm going to get started here. So, hi everybody. My name's Spencer Gietzen, and today I'm going to be talking to you about Pacu and AWS exploitation with Pacu. So, a little bit of an introduction. I'm a pen tester with Rhino Security Labs, and main focus is on the cloud, and even more so on AWS than any others. I've got a background in software development prior to my pen testing experience, and currently I'm the lead developer of Pacu and CloudGoat, which Pacu talk about today, and CloudGoats are vulnerable by design AWS environment for learning Pacu and learning AWS pen testing. So AWS security is pretty easy to get started with, but it's hard to master, and there are quite a large amount of good resources out there, like AWS documentation or white papers or just blog posts from various different researchers. But it's really difficult to know if you're doing it right and doing everything right, and so that's kind of where Pacu was born from. In a lot of cases, best practices are not going to solve all the problems that you're going to encounter, and features aren't always your friends, so something that you think was useful might come back to bite you in the butt later. Most common example of not doing it right is the thousands, seemingly, S3 bucket misconfigurations over the past couple of years, where people are just leaving their data wide open to the internet for someone to find, and over again, this example right here on the side, you might recognize it. It's looking at a listable bucket online. It's got all your phi.sql.back, credit card info.csv, clear text passwords.txt. A little bit of an exaggeration, but it almost is literally what we've been seeing over the past couple of years. And S3 bucket misconfigurations are one thing, but the real threat comes in with authenticated compromise, and you're at a much higher risk of, lots of different kinds of attacks if you lose your keys versus just somebody discovering your open endpoint on the internet. There's a lot of different ways keys can get compromised, and some of those include repo misconfigurations on GitHub, pushing some keys you had stored in a file or something like that. Social engineering and phishing to get people's usernames and passwords for their accounts. Password reuse. This is something I encounter quite a bit as a pen tester. I can go online and look at a database dump, find a clear text password for someone, and then I find that they use that same password for 10 other services, and I've owned their environment through that. It's really common. Web application vulnerabilities are even more common from what I've found. With server-side request forgery, you can contact the metadata of an EC2 instance, which gives you temporary credentials if there's an associated set of credentials for that, as well as local file read through really any method, just to read configurations, logs, and other files that might contain credentials. Trusted third parties are another big one. A lot of integrations exist where you allow a third-party access to your AWS environment to do whatever it is they need to do. So that means if they get compromised, you're at risk of being compromised. And then internal threats and rogue employees. This is something that I don't think is thought about as much, but it's a much higher risk in the sense that there's a huge barrier they don't need to overcome that normal attackers do. And it's the initial access. They've already got access to your environment, so if they're overly permissive, they could really harm your environment. In general, there's a lot of tools out there for scanning your AWS environment and checking for best practices. Some of those include Prowler, Scout2, and CloudSploit. Really good tools. I use them myself. But there wasn't much for attackers previously. There were a few tools, AWS Pwn, that's one of my favorites, Nimbostratus and Dumpster Diver, great tools as well, but something more was needed, and so really that's where Pacu was born from. So AWS Exploitation Framework, it's written in Python 3, covers the whole kill chain, so reconnaissance, enumeration, logging and monitoring, disruption, persistence, privilege escalation, data exfiltration, just general exploitation. We try and include all that in there. It's simple to start developing modules. There's a built-in template that I wrote. You can literally just look at it and start writing Python code using the Boto3 library, which is the AWS Python library. It's extensible, so there's a built-in API to assist with development. It takes a lot of unnecessary code out of your hands, a lot of repetitive code out of your hands, makes it easy to get started. And there's built-in session and data management. A session is basically just a project or a company you're working on, and it houses all the keys and everything that are associated with that session. And the various data that gets stored is basically just the data of the AWS account. So EC2 instances, S3 buckets, and tons of other things. That's all stored in a local SQLite database that's queryable from within the Pacu modules, and it's easily modifiable and readable. And then there's general error handling that you don't have to worry about corruption of the database or anything like that. It's going to handle all those errors. It's not going to blow up your screen with a huge error message, but if you want to go look into it, there's also stored files with those big errors. And just a note, it is available. I've had people think that it was not yet released previously, but so I'm going to get into the demo, the most important part of this presentation. It's a post-compromise scenario, so I've just gotten someone's keys through some method. I've compromised them. I don't know anything about them. I'll run through an intro to Pacu and just how to generally use the basic commands. Some basic account information that's not logged in CloudTrail, which CloudTrail is the main logging source of AWS. There's recent research I discovered that you can get some basic enumeration without any detection there. And then I'm going to enumerate IAM permissions for the current user. I'm going to escalate those privileges to an administrator and establish some persistence within the account. And I'm going to finish off getting root remote code execution on an EC2 instance within the account. So I've got a server set up here, or a shell. I can start Pacu just by running Python 3 Pacu. Enter, it'll pop up. It said it's found some existing sessions. I set one up for Derbycon already. So hit 1, enter into that, and we can see that the help message, there's quite a bit of help info that pops up because there's a lot of different commands you can run. Ignore it for now, but at the bottom on the Pacu shell, as I've been calling it, we can see Derbycon. That's the current session we just chose. We just logged into this session, and then there's the Derby user, and that's the active set of AWS keys for this session that I set up prior to the presentation, but these are the keys that I've just compromised. So some basic commands. Got ls, and hit enter, and that's going to list out all the modules that exist as well as the different categories that they belong to. So there's reconnaissance without the need for keys, enumeration, privilege escalation, lateral movement, exploitation, persistence, exfiltration, and evasion. There's the search command, so you can search for any module with EC2 in the name, search EC2, and it's going to print out basically the same information, except this time it's going to have a one-sentence description of what that module does, and give you a better idea what you're trying to do with that module. But there's a lot more help for each of these modules. With the help command, you could pass in a module name. So I'm going to pass it in EC2 enum, hit enter, and it's going to print out all the available arguments for that module, a long-winded description of exactly what it does, and then just how to use it and everything. So if you ever don't know what a module does, that's where to look. So there's also the set keys command. This is what I use to set up my Derby user. I don't have any keys I'm going to add right now, but I'll just show you anyways. You hit set keys, and then you can pass in an arbitrary name. I passed in Derby previously, and then you can see the access key ID for your API keys, the secret key, which gets, well, it's not censored anymore. It's all right. So it's not, well, it is censored here, and so basically that it doesn't happen, and the keys don't get posted on the screen, but it happens, doesn't matter. Session tokens for temporary credentials. These are not temporary credentials, so I don't have a session token. That's empty. So basically, that's that. And once you say I did just enter in a new set of keys, there's a swap keys command, and that'll list out all the active keys within this session. And so I don't have any others, so I can just stick with this current one. There's also It's a really important command, the set regions command. I'm going to set the regions to US West 2 because this demo is solely focused on the Oregon region. So what this does is when any module runs that accepts regions as an argument, it will first get the valid list of supported regions for the service that you're targeting, so EC2, let's say, and then it'll compare that against the list of session regions, and it will create a third list that is the regions that are in both of those previous lists. So what this does is we'll make it so that Pacu modules will only ever run against regions that are supported for a service, as well as only regions that you want to be targeting in this session. So there's no accidental stuff going on here. I can show you the whoami command, run that. We don't know anything about this user because I haven't run any commands for him, but so everything's null. But it basically just a lot of identifying information about who the user is, any groups they belong to, policies that are attached to them, as well as their permissions, which can get filled in shortly here. So going into the non-logged enumeration of the account, I created a module for that, which is IAM detect honey tokens, which basically the research ended up in being able to detect when AWS keys were honey tokens without triggering the alerts for them. Contacted the vendors, everything. They decided they fixed that. Contacted AWS about this. They said it's not a problem, and they closed the ticket. So take that as you will. Run the module. We can see the module determined these keys are real and not honey tokens as far as it knows, as well as it gives you the Amazon resource name of the keys, because this service that it uses is AppStream, which is unsupported by CloudTrail, and AppStream, as well as some other services, disclose some verbose error messages that includes this information. So now if I run whoami again, we can see the username got filled in, the ARN got filled in, and the account ID got filled in. And it's not a ton of information, but nobody knows I did it, and there's no way for them to know that I did it, really. So from this point, I can run the IAM enum permissions module, and this is going to gather the list of permissions that my current user has, so I know what I have access to. And we can see it confirmed permissions for Derby, and we get a module summary for every module that runs. And it says we confirmed permissions for Derby and then 0 roles. It also supports roles. The idea is if it just confirmed permissions for 50 different users and 25 roles, that would fill up your whole terminal, but the summary would give you a better idea of what exactly went on if you didn't want to go reading through all of that. So now if I run whoami again, we can see that this information got filled in, the rest of it. We got the user ID, just all this top stuff's identifying information about this account, not all that important right now. These are the policies that are attached to that user. So I have one policy, the IAM manage self policy attached. And then permissions confirmed is set to true, which means that my user had the right set of permissions to determine exactly what permissions it has, if that makes sense. Kind of weird point, but it's possible to not have that permission and for this set of permissions here to get filled out but not be complete, and so in that case it would be false. We can see under allow, I'm allowed the IAM list star permissions, and star is a wildcard in IAM policies. They're just JSON documents, so a star means I can run any list command within the IAM service, and then resources are just resources within the AWS account, and I have that permission on any resource in the account. Same goes for IAM get permissions. And then I have the IAM put user policy permission, which is allowed only on this single resource. And this is the ARN or Amazon resource name of a user that is in this account right here. This 12-digit number is a user, and it has the developer path name associated with them, which we know my user does from right here. And then AWS username right here, this is an IAM policy variable that when you execute an API call, that's going to resolve to who is executing that API call. And so basically I can only run the IAM put user policy API call on my own user. As another example, I included the IAM generate permission, which has a condition that I only have that permission if I'm multi-factor authenticated with AWS, and it's not important right now, but it's just an example of what this kind of information shows when you run that. So we know that I don't have any EC2 permissions, but just a quick example, I can run the EC2 enum module, pass it the instances argument, and it's going to fail. It says I don't have permission to run describe instances. That's what we expected. So I'm going to escalate my privileges now, hopefully. I can run the IAM privesc scan module, and basically this module will scan my permissions for 21 different privilege escalation methods to determine what it has access to, and then it will try to exploit any of the available methods through that that show up. So hit enter. So it happens quickly. We can see that confirmed put user policy, that's one of the methods that it discovered, put user policy, and that's the only method, otherwise they'd be listed there. So then it's going to attempt to start exploiting that privilege escalation. It's going to use it to add an administrator level policy to this current user, and then it tried that and it was successful, and it created this policy with administrator level permissions. So, you know, it doesn't look like much, but I can run the IAM enum permissions module again to get my new set of permissions. And if I run who am I again, we can see right here at the bottom of the allow permissions, I have star permissions on star resources, which means I can run any AWS API call on any resource within the AWS account. So basically, that's an administrator level access to this account. So to show that even further, I can run the EC2 enum module again, and this time it's going to work. I found one EC2 instance in the US West 2 region, and so we know that I actually do have those administrator level permissions. In terms of persistence, because of well, time constraints, I'm not actually going to run through these modules, but I'll describe them a little bit. So there's the EC2 backdoor security groups module. It's going to whitelist an IP range of your choice to any security group within the account, so then you'll have access to the various servers and services that are available. There's backdoor assume role, which will give your user permission to assume other roles in the account, which could give you 12-hour, I think 12 hours is the maximum access to those roles as you get a new set of keys, basically. And then there's the IAM backdoor users keys and password modules, which will add either a set of keys or a password to other users in the account, and you can have access to all their permissions that way. And just recently I added these 3 modules from AWS Pwn. I ported over some scripts that Daggers had written, and basically what they'll do is they'll launch a Lambda function and a CloudWatch events rule into your account that will monitor the IAM service. So every time a new role is created, it will automatically backdoor it with your account and then exfiltrate the role's Amazon resource name or ARN to your server. So then you know you can go and assume that at any time. Or with security groups, it'll backdoor it with your IP every time someone creates a security group. And for new users, it'll backdoor a new user with a set of keys, and it'll exfiltrate those to a server that you've set up. And then you've got literally access, unlimited access, until they figure out that this is going on. So we'll say we just established some persistence. From this point, I'm going to get some code execution on that EC2 instance we discovered. And there's a couple of modules that do that. There is the Systems Manager RCE EC2 module. It uses AWS Systems Manager to get root or system code execution on various EC2 instances that it doesn't require a restart, doesn't require anything. It's pretty simple if you have the permissions to do it and the operating system is vulnerable. But it's a little finicky with time, and so it's not a very good module to show in a presentation. I'm going to show the EC2 startup shell script module, which will stop an instance, change the user data of it, which the user data is basically just an arbitrary set of script or data or whatever that you want to supply to the instance that the instance will then have access to. But there are directives you can pass in that will instruct the instance to run this section of code that you stored in the user data on startup. And it runs as root on Linux and system on Windows. Pretty easy and pretty simple set of permissions that it takes to do this. Obviously, it's a problem to stop an instance in an engagement or something like that, but if you are able to do it, it's a real easy way to get code execution. So I've got another server set up here. I'm going to set up a netcat listener on port 5050. Just going to listen for my reverse shell that I'm going to send it here in a second. And then I'm going to run the, let's see, EC2 startup shell script module. I'm going to pass it a script that I've already written, reverse shell.sh, and it's just a bash reverse shell that points to that server that we're listening on right now. So we'll run this, and it's going to target every EC2 instance because I didn't instruct it to target any particular ones. It's going to immediately start stopping it, and once it stops, it's going to start setting the user data for it, and it's going to insert my script without screwing up the user data. At least in my experience, it will add in this script without screwing up the previous user data that they have set up for their instance. So you wouldn't be necessarily causing any denial of service or anything like that. So now the instance has stopped, and it started it up again. And once the instance starts, we'll see on the reverse shell that during the boot process, it's going to read that script and execute it as the root user, and it's going to make a callback to this server I've got running. And this is always a little nerve-wracking. I know it's going to work, but it takes a second. So there's the shell that came in, the root user. You can run who am I, and that's the root user. So that wraps up the demo here. Pop back to the slides. Basically in conclusion, there's a lack of security tools or AWS security tools in the industry, and that means there's a lack of AWS security awareness because people don't know what's possible in their environments. They don't know what the features can do. We're going to try and solve that with Pacu. That was the goal, and more offensive research from myself and hopefully from the community as well, and make it easier to understand what's going on and easier to secure your environments. I've included some resources here. This blog post that describes the 21 different privilege escalation methods that the privilege escalation scanner checks for. I described each method as well as how to manually exploit each of those methods in there, so that will give you a better understanding of what that module is doing, as well as the Pacu repo. And then there's my email there if you want to get in contact, and my Twitter is at @SpenGietz. So you can follow me or hit me up on there. So that kind of wraps everything up. I want to thank everyone for coming and listening.